Imagine you're at a grocery store and you need to pick up just a few items. But instead of heading straight to where your items are, you wander through every section, checking out every shelf before making your selection. Sounds inefficient, right? That's exactly how poorly optimized SQL queries work. SQL is the backbone of database management. It helps retrieve, manage, and also organize data efficiently. But if your queries aren't optimized, they can slow down servers, increase load times, and waste valuable resources. This is why SQL query optimization is so important. It's the difference between a query that runs in milliseconds and the one that drags on for minutes. Let's take a simple example. Suppose you are searching for customer details in a database. You write a query like select star from customers where city, suppose it's Los Angeles. So at first glance, it seems fine. But here's the issue. You will pull all the columns of the data even if you only need the customer's name and the email. This makes the query slower and unnecessarily heavy on the database. So instead, an optimized query like select name, email from customers where city is equals to Los Angeles. This will retrieve what's needed, reducing load time and improving performance significantly. So in this video, we will explore the 12 best practices for SQL query optimization that will help you write faster, more efficient queries such as using indexes effectively, avoiding select star and retrieving only necessary columns, optimizing join operations, minimizing the use of subqueries, leveraging the stored procedures for performance boost. And by the end, you will have practical strategies to improve your SQL performance and ensure your queries run at lightning speed. So let's start with our first practice for SQL query optimization, which is using indexes effectively for SQL query. First of all, imagine you're looking for a specific word in a 500-page book. Without an index, you would have to flip through every single page until you find it. But with an index at the back of the book, you can jump straight to the right section in seconds. And that's exactly how indexing works in SQL. It acts as a shortcut that helps the database find and retrieve data much faster. But then why indexing actually matters? When a query runs without an index, the database has to scan every row to find a matching data. But with the help of indexing, it knows exactly where to look, cutting down search time significantly. However, it's important to use indexing wisely. While it speeds up data retrieval, it also adds overhead when data changes frequently because indexes need to be updated. Now let's discuss the types of indexes and when to use them. At first, we have clustered indexes. You can think clustered index as a library where books are arranged in perfect order by title. Clustered indexes physically sort and store data based on actual column values. They work best for sequential, unique data like primary keys. Now let's talk about non-clustered indexes. Now you can imagine a library catalog that lists book titles separately. With the help of reference number pointing to their shelf location, that's how non-clustered indexes work. They create a separate lookup structure that points to the actual data. This is useful for lookup tables, mapping relationship, or glossary style searches. Now let's talk about the third type of index, which is the full text indexes. Full text indexes are basically indexes that search for a keyword in a massive document or email. Full text indexes help by storing word positions, making searches much faster instead of scanning the entire text. Let's look up for an example how indexing speeds up queries. Let's say you're searching for customers by name. So without an index, the query scans every row. So there you have to write a query like select star from customers where name is equals to, let's say the name is John. So this takes longer, especially in large data set, but by creating an index on the name column, the query runs much faster. So you have to write query something like create index IDX customer name on customer name. So now as you can see, the database can quickly jump to the exact row, saving valuable processing time. So basically, in cloud-based databases like Redshift and Snowflake, indexing doesn't work the same way. Instead, these systems automatically partition data based on query patterns. So, sorting data before loading can improve performance. Indexes are one of the best ways to optimize SQL queries. When used correctly, they speed up searches, reduce server load, and improve application performance. But remember, not every column needs an index. Use them strategically for frequently searched data to get the best results. Now let's talk about the second practice is that why you should avoid using select star and only retrieve necessary columns. Let's say you're ordering food at a restaurant, you just want a burger, but instead of ordering it separately, you ask for the entire menu, appetizers, main courses, desserts, and drink, even though you don't need them. It sounds ridiculous, right? That's exactly what happens when you use select in SQL queries. Why is this a problem? Because when you use select in your queries, you're asking the database to retrieve every single column, even if you need only a few. Basically, this puts unnecessary load of the database, which slows down query execution, and then it clutters reports with irrelevant data. So instead of using select star from customer profiles, you could use select customer name, customer email, customer phone from customer profiles, which is the table name. So while using this type of query, this will make your query much more faster, optimized, and efficient. So when should you use to avoid select? So basically when you're preparing reports and dashboards, which includes column that businesses users actually need to be. You can also avoid select in data models to keep queries clean by excluding unnecessary fields. For performance optimization, because less data retrieved will give you faster execution on time. Remember, using select is just like carrying extra baggage. It slows things down and makes everything harder to manage. Be intentional with your queries, select only what you need, and watch your database run smoother. Now let's talk about how can you optimize join operation for faster queries. Joins are basically which can make or break your SQL queries. So if you use the wrong type of join, you might end up with duplicate records, which slows query optimization or unnecessary data bloating your results. And that's why understanding inner join, outer join, left join, and right join is very important for writing efficient queries. First of all, you should use outer joins with caution. Think of outer join like dumping the contents of two spreadsheets into one, keeping everything from both, even the unrelated data. Sure, it might sound useful, but it can create duplicates and bloat your dataset unnecessarily. Unless you have a very specific use case, it's best to avoid outer join and stick to more optimized options. Now let's talk about the inner joins, which would be your best friend. An inner join is like matching puzzle pieces. It only returns records when there's a match between both the tables. This is almost always the best choice for keeping your dataset clean and ensuring that you only get the necessary data. For example, we have a query over here like select, let's say customers orders, customer ID, order details dot order date. We are joining two tables. So first table is customer orders and the second table is customer ID. From customers dot customer order, and here we are using inner join orders dot order details on customer orders. So as you can see, we have used inner join over here. So by joining on multiple columns, you can ensure that only valid matches are retrieved, reducing duplicates and improving the performance. But then let's talk about which is better, left join or right join. Left joins keep all the records from the first table and only the matching records from the second table, remember. Whereas the right joins do the opposite. They keep all the records from the second table and only the matches one at the first table. Remember, always try to use left join instead of right join because it's easier to read, improves data governance, and makes debugging less confusing. If needed, simply swap the order of your tables to make a left join work. So some of the pro tips I would say for faster joins is always use join on a common field. Make sure the columns exist in both tables. Use primary and foreign keys. This helps the database retrieve results faster. Consider joining on multiple columns. This can reduce duplicates and improve query efficiency. So by optimizing your joins, you will speed up query execution, reduce unnecessary data processing, and then improve overall database performance. Smart joins is equals to faster results and smoother operations. So now the question is, why should you use exist instead of n? So this is one more practice where you should use exist instead of n. So let's say you're searching for a friend in a huge crowd. If you use in, it's like scanning every single face before confirming whether your friend is there or not. But if you use exist, the moment you spot your friend, you stop searching. Which one is faster? Obviously, exist one. That's exactly how it works in SQL. When checking if a value exists in smaller dataset, exist is usually much faster than in, because exist stops searching as soon as it finds a match, whereas in scans the entire dataset before deciding, which makes it slower, especially with large tables. So instead of using query like select star from orders, where order ID in select ID from customer where active is equals to you, true, you can use something query like select star from orders. Let's say the order table is O, where exist, we're using exist over here. Select one from customer, and in this way, what is happening? Because exist will check if at least one active customer exists for an order and stops it immediately after it finds a match. So if you use exist, it will make it faster and more efficient and then scan the entire dataset within. If you're wondering, with large databases, switching from in to exist can significantly improve performance and speed up query execution. Less scanning will give you more efficiency. Let's move on to the fifth practice, which is we should minimize our subqueries and use CTEs instead. Let's say imagine you're trying to untangle a giant ball of wires, which is messy, confusing, and frustrating. That's exactly what happens when you rely too much on subqueries in SQL. They might get the job done, but they can make your queries hard to read, debug, and optimize. A much better approach is using CTEs, which is common table expressions. CTEs break your query into smaller readable sections, making it easier to understand, troubleshoot, and maintain. So instead of stacking multiple subqueries inside a single query, CTE lets you organize your logic step by step, just like writing a clear set of instructions. Let's suppose you're converting a subquery into a CTE. So here's a messy subquery like select max as most recent signup from the table name from wherever you want to select, customer name with customer phone, from customer details where the year is this much. So how can you optimize with the help of CTE, which is you can use with 2023 signup as select customer name, customer phone, customer signup from customer details where year is equals to this much, most recent signup as, and then you can give the table name and select whatever sections you are selecting from 2023 signups, and then select most recent signup from most recent signup. Okay, so why is this query much more better and optimized? Because as you can see, it is much more easy to read. So each section is clearly labeled, making it simple to follow. Also, it has got better debugging. You can run individual CTEs separately to test logic. It has improved maintainability so that anyone reviewing your code can quickly understand what's happening without digging through nested subqueries. So if your query looks overwhelming, consider breaking it down with CTE because clean code will give you faster queries and easier troubleshooting. Now let's talk about why should you avoid queries inside a loop. So imagine you are at a checkout counter with 100 items, and instead of scanning them all at once, the cashier scans, processes, and then prints a receipt for each item separately. It sounds painfully slow, right? That's exactly what happens when you run SQL queries inside a loop. It makes execution unnecessarily slow and inefficient. But why is this a problem? Because loops like for while and do while execute queries repeatedly, one at a time. This means every query has to go through the full process of parsing, compiling, and execution for each iteration. As a result, performance takes a huge hit and scalability will suffer. So the better approach is using the bulk operations. So instead of running queries inside a loop, batch process them all at once. SQL is designed to handle bulk inserts and updates, which is far more efficient than executing a query repeatedly. So here we have a slow method, which is a query inside a loop, which is for each customer in customer list loop, update customer set. So inside a loop, we have this update customer set status is equals to active, where ID is this much, and then we will end the loop. So this executes one update at a time, which slows down performance drastically. Now here we have an optimized approach, which is bulk update in one query, where we will be writing update customers set status is equals to active, where ID in select ID from ID name. So here, as you can see, we haven't used the loop. So this updates all the rows at once, making execution very faster and more efficient. So if you catch yourself writing a query inside a loop, pause and rethink. There's almost always a better bulk-friendly solution. Now let's move on to the 7th practice, which is why you should avoid redundant or unnecessary data retrieval. Imagine you're shopping online and instead of just searching for running shoes, you browse every single category, clothes, electronics, furniture, just to find what you need. Not only at this time consuming, but it will also slow down everything. That's exactly what happens when you retrieve more data than necessary in SQL. The larger the data set, the slower the query, and the more resources you waste, which can increase costs, especially in cloud-based databases. So how can you optimize data retrieval? First of all, you have to select only the needed columns. We have already covered why select is inefficient, but it's also important to limit the number of rows returned, not just the columns. Second of all, use limit to control output. Queries that return thousands or millions of rows can drag down performance, so always limit the results when needed. For example, using limit for efficiency. So here, instead of pulling all the customers, retrieve only the latest 100 signups. So here, as you can see, we have a query where you can select customer name from customer details, order by name, and limit is equals to 100. So this ensures that only 100 rows are returned, even if the table has 1000. If you want to skip the first 20 rows and get the next 100, you have to use offset. So if you are using offset, you have to write a query like select customer name from the table, order by customer signup DECD, which is order descending, limit 100, offset 20. So by using this offset, this is useful for pagination when loading data in chunks instead of all at once. Cloud databases like Snowflake and BigQuery help optimize queries by caching results, meaning repeated queries run faster, so you can also use temporary tables to store frequently used query instead of recomputing them every time. Now let's move on to the 8th number of our best practice, which is why you should utilize stored procedure. Imagine if every time you needed to bake a cake, you had to measure ingredients, mix the batter, and follow every step from the scratch. It sounds exhausting. Instead, wouldn't it be easier if you had a pre-made cake mix that just needed a few tweaks? That's exactly what stored procedures does for SQL. They act like a pre-written reusable function that saves time, simplify logic, and then also boost performance, especially for frequently executed queries. First of all, it gives you faster execution. Stored procedures compile and cache queries so that they can run much more faster than writing SQL statements. Second of all, it's reusable and automated. So instead of rewriting the same query, you can call a stored procedure whenever you need it. Third of all, it's easier to maintain. Changes to the procedure automatically apply everywhere it's used. So avoid redundant edits. How can you create a stored procedure? First of all, let's say we want to find the most recent customer sign up. So instead of writing the query every time, we can save it as a stored procedure. We can write a query like create procedure, find most recent customer as begin, select max, customer sign up as most recent sign up from 2023 signups, and then we can write end. So now whenever we need this query, we simply execute exec find most recent customer. You don't have to rewrite the SQL, just call the procedure and get the result instantly. So as you can see, just by writing this simple procedure query, we can just retrieve all our data. Second of all, let's talk about adding parameters for flexibility. If we want to filter by store ID, we can modify the procedure to accept a parameter. For example, we can create a procedure, find most recent customers, store ID as begin, select max from sign up, where store ID is equals to name, and then end. So now we can pass a store ID dynamically when executing the procedure, which is exec find most recent customer, store ID is equals to, and just name the store ID. Suppose it's 1188. So this will make your procedure highly flexible while still being reusable. So basically, stored procedures are a game changer for SQL performance. By compiling, caching, and automating frequently used queries, they speed up execution, reduce redundancy, and make SQL development much more smoother. Now let's talk about the ninth type of best practice, which is why you should normalize your database. So think of your database as a well-organized bookshelf. If books are randomly stacked, finding the right one takes forever. But if they're sorted by genre, author, and title, everything becomes easy to find and retrieve. And that's exactly what normalization does for SQL databases. It will organize data efficiently, making queries faster, reducing redundancy, and improving accuracy. So normalization is important because it keeps data well structured and easy, it reduces redundancy, and it improves performance. So first level of the normalization we are going to talk about is the 1NF, which is known as the data. So have you ever seen JSON objects inside a database column? That's a sign of poorly structured data. 1NF ensures that every value is atomic, meaning it can't be broken down further, that each row has a primary key. For example, instead of storing customer address as JSON, break them into separate columns. As you can see in the table, we have broke this into separate columns. In the branch name, we have CS as well as civil also. So we have atomic data stored, like individual data. We cannot use multiple data at the same time. Now let's talk about the second type of normal form, which is this split value field. So if a single column stores multiple values, querying the data gets tricky. 2NF ensures that each value has its own row while still being linked to the primary key. For example, instead of storing multiple phone numbers in one field, separate them into a new table linked to the customer ID. Now let's talk about the third type of normal form, which is the 3NF, which has remove column dependencies. Think back to the high school geometry. Remember the transitive property: if one column depends on another, we will move it to a separate table. In the similar way, in a customer table, storing zip code and state together is redundant. Instead, move zip code to a separate table and then link them to the state. In this way, if a state zip code changes, you only update one table, not every customer record. So while higher normalization level exists, most databases don't require them unless handling very complex relationship. Sticking 3NF is usually enough for efficiency and performance. Now let's talk about the 10th type of practice, which is why monitoring query performance is very important. Imagine you're driving a car but never check the speedometer, fuel gauge, or engine health. You wouldn't know if you are wasting fuel, driving too fast, or if your car is about to break down. That's exactly what happens when you run SQL queries without monitoring their performance. You have no idea which queries are slowing down your database or costing you extra resources. So why is monitoring query performance matters? Because it identifies slow queries. You won't know which queries need optimization if you never check their runtime. Second of all, it saves costs in cloud databases, so reducing execution time can significantly cut cloud resource cost. Third of all, it prevents system slowdown. Poorly optimized queries can drain server performance and it can impact user experience. Now let's talk about the tools for monitoring query performance. First tool is query profiling. This technique helps analyze query runtime, number of rows returned, and execution ordering to identify bottlenecks. The second one is query execution plans. These show how SQL queries are processed, revealing which operations takes the most time and which improvements can be made. Third is database logs and server monitoring. Checking logs can uncover slow queries, high resource consumption, or external applications affecting performance. Now let's talk about the example. Let's say you have a slow query and you want to analyze its performance. You can use MySQL explain statement. Explain select customer name from customer where city is equals to, let's suppose it's New York. This will show you how MySQL processes the query, which indexes are used, and where the potential slowdowns are happening. Regularly check your databases, slow query, and execution plans. So if a query takes too long, don't ignore it. Optimize it. A few small tweaks can make it a huge difference in performance and cost savings. You can't optimize what you don't measure. So by monitoring SQL query performance, you can fix slow queries, improve efficiency, and then also reduce unnecessary cost, keeping your database running at top speed. Now let's talk about the 11th type of best practice, which is why you should use union all instead of union. Imagine you're merging two guest lists for an event. If you use union, you are double checking every name to remove duplicates before finalizing the list. But if you use union all, you simply combine both lists as they are, faster, simpler, and without extra processing. That's exactly how union all works in SQL. It joins two datasets without checking the duplicates, making it much more efficient than union. So basically, union combines results from two tables and removes duplicates, which takes extra processing time. Union all combines results without checking for duplicates, making it faster and much more efficient. Let's look at an example. Union versus union all in action. So here we have union. It's slower because it removes duplicates. So try avoid using a union. We have a query like select customer name from customers and we are using union. Second of all, while we are using union all, we have a query like select customer name, union all. So why is this best for performance optimization? It's best because it specially removes duplicates which doesn't matter or which can be handled later. If removing duplicates isn't necessary, then always use union all because it's faster, reduces processing time, and improves SQL performance. So if you must remove duplicates, try handling them later using distinct instead of forcing union to do the extra work upfront. Now let's move on to the last part of our best practice, which is why you should leverage cloud database specific features. So imagine you're using a high-end smartphone, but instead of exploring its built-in AI features, fast charging, or cloud sync, you are only using it for basic calls and text. You are missing out on a powerful tool that could make your life easier. And that's exactly what happens when you don't take advantage of cloud database specific features. Cloud providers like Snowflake, BigQuery, and Redshift come along with built-in optimization and custom SQL function designed to improve performance, simplify queries, and handle data more efficiently. So why you should use cloud specific features? Because it's optimized performance, built-in functions, and cost efficiency. Now let's look at an example, Snowflake's JSON function. So Snowflake has special function for passing JSON data directly in SQL, something that would make be harder and slower in traditional databases. So let's suppose the query is select JSON column customer name, string as customer name, JSON column, and here from orders. So instead of writing complex parsing logic, Snowflake lets you query JSON fields like normal columns, saving time and improving performance. Every cloud provider, AWS, Redshift, Google, BigQuery, Azure, Snaps, or even Snowflake has unique optimization. Check their documentation for performance tuning tips, built-in functions, and query optimization strategies to get the most of your cloud database. Just a quick information, if you're interested to make a career in data analytics, you can check out Simplilearn's postgraduate program in data analytics. This comprehensive course is designed to transform you into a data analytical expert. The program covers essential skills such as data visualization, statistical analysis, and machine learning using industry-leading tools like Excel, R, Python, and Tableau. With expert instructors, real-world projects, hands-on practice, you'll also gain the knowledge and confidence needed to excel in today's data-driven world. So join now, and you can find the course link in the description box below and in the pinned comments. So by this, we have come to the end of our topic today. So if you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. I'll see you in the next video.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.